Okay, for today's questions, there is no new maths to learn. We are just using everything we've learnt so far, but this time they will be worded questions. Today's lesson is dedicated entirely into turning a worded question into a picture or into a diagram. Then the maths is all the same as what we've been doing. What I want you to do with these questions is, as the information comes up, try and draw an actual picture. Now, we know that we're going to end up with a triangle, so there's a bit of a clue, but don't just draw a triangle. So this first question says a ladder is leaning up against a wall. I want you to draw a ladder that leans up against the wall. Now, it doesn't matter what direction it faces in, but for my picture, I'm going to have the wall on the left-hand side of my page, if you want yours to be the same. I'm not going to be pausing through this video or telling you to pause through this video. You just need to try and stay ahead of what I'm asking. So right now, try and draw a ladder against a wall. And then let's start labeling this ladder on the wall. So the ladder is 2.3 meters long. Pause this video at any time if I'm going ahead of you. I don't want you copying from my pictures. I want you to try it on your own first. Now, the foot of the ladder is 1.9 meters away from the base of the wall. So think of where the foot of the ladder would be. Foot, of course, would be at the bottom. And then it says 1.9 meters away from the base of the wall. So far, I'm hoping you've got a picture with some numbers on it, but these questions are always going to be asking you to find something out. So you're either going to have to find out how long something is or the angle, the degrees of something. This question says, what angle does the ladder make with the ground? Now you're finding an angle. That means I want you to put a little theta sign somewhere in your diagram. So somewhere in your diagram, you need to put a theta. And the clue is the theta goes where those two things meet in the question. So it says ladder and the ground. Have a look at your picture. Where does the ladder touch the ground? That's where you need to put a theta. So let's go through it step by step. We'll see if we've done the same thing. Here's my diagram of a ladder against a wall. Next, the ladder's 2.3 meters long. So you make sure, again, pause it if you want to change yours. Make sure you've put 2.3 meters on the ladder, like that. Now it says the foot of the ladder, which means the bottom of the ladder, is 1.9 meters away from the base or the bottom of the wall. Well, that's across the bottom there, isn't it? That's between the foot of the ladder and the base of the wall. Now you have to put a theta somewhere. What angle does the ladder make with the ground? Your little theta has to go in there because that's where the ladder touches the ground. Now, again, pause it and do it before me. Label your triangle with the letters O, A, and H. Put a hypotenuse, opposite, and adjacent in the right spots. When you're done, come back and we'll see if it's the same as this one. So your hypotenuse should be on that side there. Your opposite is the side that the theta is looking at, so it should be on the wall there, which means your adjacent must go across the bottom there. Now, pause it and write down what your trig ratio should look like. That is, write down what your equation should be. Decide whether to use sine, cos, or tan, and write it out. Once you've written it out, it should look like this. We've decided to use cos. We don't know what the angle is, so we put a theta in between, and then equals A over H. That is 1.9 over 2.3. Again, press pause. You need to use cos -1 because that's what it means whenever we're finding an angle. Look through your notes if you're not sure what to do. See if you can write down what the next step would be. The next step will look like that. And that is exactly what we type in our calculator. What angle does the ladder make with the ground? If you type it in your calculator, you'll have your answer. Let's have it to the nearest degree, so no decimal places. If you've typed it in correctly, you will find out that that answer is 34 degrees. Now, final step. That's great. You've got everything correct. You need to do one more thing. This is a worded question. That means it needs a worded answer. So, pause and write down in words a sentence what that 34 degrees means. The blue sentence up the top can give you a clue, the last sentence. The best way you could have written it in words is the ladder makes an angle of 34 degrees with the ground. All right, and that's perfect working out. We're going to do 3 more examples. We'll go a little bit quicker as you get the hang of it, but the hardest bit is turning the words into a picture. Let's do one very similar so we can get the hang of it. Here's another ladder leaning up against the wall, so draw it again. Stay ahead of me, but pause this video anytime you need to. The ladder reaches 1.4 meters up the wall. Please read that carefully. It doesn't say the ladder is 1.4 meters long. It says the ladder reaches 1.4 meters up the wall. Then it says the ladder makes an angle of 39 degrees with the ground. So look at where the ladder touches the ground. That angle in there is 39 degrees. This time it's saying how long is the ladder. It's asking you to find a distance or a length. So this time you've got to put an X somewhere on your diagram. Here's your diagram, decide where the X needs to go. Let's see if we labelled the same way. First thing we have to do is the ladder reaches 1.4 meters up the wall. Well, that's that number along there. Because see now, that ladder is touching 1.4 meters up the wall. Then we said the ladder makes an angle of 39 degrees with the ground. It goes in there because that's where the ladder touches the ground. When I said how long's the ladder, you've got to put an X somewhere. We'll put it on the ladder because that's what we're trying to find out. Now that you've done that, label again, press pause, label your 3 sides of your triangle. Once labelled, hypotenuse goes where the X is there, it's the diagonal side. That 39 degrees is looking at the 1.4, so that's your O, which means A is down the bottom. Again, pause it, decide whether you use sine, cos or tan, write down what your equation would be. Your equation should have, or you should have decided to use sine, and then we end up with this equation here, okay? Opposite over hypotenuse, O over H gives us 1.4 over X. Again, press pause. We'll look back what you need to do when the X is on the bottom of the fraction. I'll give you a clue, it involves some swapping around. So look back in your notes if you need to, and work out how to get the X by itself so that we can type it in the calculator. All right, once you're done, again, make sure you're staying ahead of the black. Once you're done, see if yours looks the same as this. The X and the sine 39 have to swap places, is what the rules should have told you. Now you can just type that in your calculator. Not the X equals part, type the fraction in your calculator, press enter, and then see if you get the same answer as me. Your answer is X equals 2.22. Now, that's fantastic. Let's put it into words. A really short sentence, only going to be 4 or 5 words long. Explain to me what 2.22 meters means. Look at the blue sentences to help you out. Okay, once you've written it, again, pause it if you haven't written it yet. Your answer should read, the ladder is 2.22 meters long. Let's try another one. Something a bit different this time. Imagine this, you're at a party, everyone's having a lot of fun, and there's always that one girl that takes it a little bit too far. And this girl decides it'd be a really good idea to twerk up against the wall at the party. So she is ready to put on a show for everyone to watch. So here she is. Picture this, again, try and draw that in a diagram, okay? If you can, just draw your best drawing skills, what that would look like. When outstretched, her feet reach 2.1 meters up the wall. So work out where that 2.1 needs to go. That's how far her feet reach up the wall. It's not how long she is, that's how far her feet reach up the wall. Then, her hands are 1.3 meters from the base of the wall. Put a 1.3, that's how far her hands are. So picture what it would look like if she's twerking up against the wall. Her hands are going to be on the floor. So it's 1.3 meters away from the base of the wall. And I'm asking you to find out what angle do her hands make with the ground. So we're finding an angle, you're going to have to put a theta somewhere. what angle do her hands make with the ground? Put a theta wherever her hands meet the ground. So to visualize it a bit better, you're picturing something like this. All right, here she is. She's having the time of her life. We know that every shape in this diagram is going to be a triangle. So we need to imagine that into a triangle. It might be easier to just draw a triangle like that. On this triangle, if you still need a bit of help, draw that and then work out which side of that triangle would be the wall. Well, that would be the vertical side there. The wall is always straight up and down. And then of the triangle, work out which part of that triangle, which side would be the girl that's twerking. Well, it'd be that one there, because that's how she'd be leaning up against the wall. Now, let's see if we've got our numbers in the right spot. Her feet reach 2.1 meters up the wall. Pause it if you haven't done it yet. If you have, your 2.1 should be there. That's how far her feet reach up the wall. And then it said her hands are 1.3 meters away from the bottom or the base of the wall. So her hands are on the floor, which means the 1.3 must be there. That's between her hands and the wall. And the question I asked is, what angle do her hands make with the ground? Well, where her hands and the ground touch, that's where your little theta needs to go. That's in the corner down there. So we're moving pretty quick, but remember, you need to be pausing so that you're doing this before I do. Pause now and label the sides of the triangle, H, O, and A. Once labelled, you've got your H on the diagonal side there. You've got your O, the theta is looking at the 2.1, so it's there, which means the A must go down the bottom. Pause it again, decide whether to use sine, cos, or tan, and write down what the equation would look like. The equation, once all together, would look like that. Tan, we don't know the angle, so we put a theta in there, and the fraction is O over A. Again, press pause, look back in your notes, work out what to do when we're trying to find theta, and write out what the next line would look like. It looks like that. And once you get to that step, the calculator will do the rest for you. Type that in and you'll get an answer. Let's have the answer to the nearest degree. So no decimal places, the nearest degree. 58 degrees is your answer. The last thing we need to do, remember, worded question needs a worded answer. Write your 58 degrees in a sentence describing what that means. Use the blue sentence up the top to help you. Your sentence should read something like this. Her hands make an angle of 58 degrees with the ground. And that's a perfect response. One more question. Again, different scenario. This time, you've got a building that's 160 meters tall. So just draw a building. Draw a big building. When you're ready, the next line says, it has a wire attached to the top of the building running diagonally to the ground. So you now need to draw a wire that's stuck to the top of the building. Diagonally is a big clue there that runs down to the ground. So make that part of your diagram. Once you've done that, the wire makes an angle of 47 degrees with the ground. So you need to put a 47 degrees. Look at the two words in that sentence, wire and ground. You need to put a 47 degrees where the wire meets the ground. And the question that this is asking is, how long is the wire? So we want to know how long something is. Whenever you see how long, you're putting an X somewhere on your diagram. Let's start with our diagram, something like that. We've got a building and there's a wire coming off it. Doesn't matter if your triangle faces the other way, it'll still be all the same information, it will give you the same answer. The first sentence tells us the building is 160 meters tall. So put 160 meters on the side of the building. Should look like this. Next, pause and do it before me if you haven't already. It has a wire that runs diagonally to the ground. So we've got that in our picture. 47 degrees needs to go somewhere. You need to put that where the wire touches the ground. Well, that should be just here. And the last question is asking us, how long is the wire? Put an X where you think that needs to go. How long is the wire? It belongs there. That's the wire. All right, label your sides. Press pause, label them O, A, and H. Our hypotenuse is the diagonal side. That's there with the X. The opposite side, the 47 is looking at that 160, so the O goes there. And the A, of course, is the one down the bottom. All right, press pause. Decide whether you use sine, cos, or tan. Write out your equation. All right. Should look like this. We've got O and H. That's SO, so we have to use sine. The angle 47 goes next to it. The fraction tells us O goes on top and H goes on the bottom. That rule should be written at the top of, I'm hoping, every page in your book. Keep flicking back if you need to, though. All right, similar to the one before, the X is on the bottom. So work out what needs to be done to get the X by itself, and then we can type it in the calculator. All right, should have already written down now the next line. It would look like that. The X and the sine 47 swap places. Now that they've swapped places, type it in the calculator. You'll get an answer. Let's have this answer to 2 decimal places. Your 2 decimal places give you 218.77 meters. That's what X equals. Interpret that. Worded question needs a worded answer. Use the blue sentences to try and turn that into a sentence. All right, once you're done, your sentence should read something like, the wire is 218.77 meters long. Okay, that was pretty quick, so I'm hoping you paused it when you needed to try and work it out. Otherwise, refer back to this video as often as you need to. You can now work through the questions that I've given you. And if you need any help, you come back anytime you need to.